Thank you for the opportunity to speak. I'm going to be talking about the different resources we develop for distance learning in the STEM coding project. Before I jump into that, I just want to show you a video of one of our activities, which is sort of, in a nutshell, kind of what we're saying is appropriate and useful and fun to do in a classroom right now. So this is the Asteroids game that we developed. So initially this ship only moves in one dimension, and you have to modify the code to get it to go in 2 dimensions and rotate and all those things. The student ultimately gets a game they can actually play that illustrates the velocity and acceleration vectors. But it also illustrates things like inertia. So by changing the mass of the ship, you can see how that changes how the ship handles in the asteroid field, how long you can survive. And so the students sort of learn inertia not from me telling you what inertia is, but just from playing the game itself. And so this is kind of broadly what we think is appropriate and fun and good and useful and to promote learning in the classroom. So I'm going to be talking about that and other activities in a minute, including our YouTube channel. We have a learning management system that we use to facilitate using these activities in the classroom, which is very important, especially with distance learning. So I'm going to talk about that in a minute. And then the last thing I want to talk about is analyzing videos to get the position of objects, which a lot of people are doing right now in distance learning, and so we have our own approach to that. Way back when in 2016, there wasn't much on ourcode.com, which was the world's most popular computer science website and computer science education website. And so we set out to develop some activities for that, sort of mostly focused on the theme of the physics of video games. And so the last 3 years, except last year, 2020, we posted activities here. So this is our physics of video games activity. And we opened this one with a discussion of Mario Kart. And we asked students to identify all the things that would happen in Mario Kart that would not happen in real life, even if it's silly things like floating bananas and turtles driving cars. But we're trying to get them to see that the computer is making certain assumptions as it represents this world. And because ultimately our goal in sort of integrating computer science into introductory physics and physical science is not that we're trying to make a new generation of computational physicists or software engineers. What it boils down to is that simulations are an important part not only of everyone's lives with the way that the COVID modeling has affected our lives, but even traditional engineering disciplines, simulations are mattering more and more, even if people do not have detailed computational physics or software engineering backgrounds. And so Mario Kart gets them kind of thinking about what these things are doing, because someday there's going to be some commercial program that your students might need to use to accomplish some task, and they need to have some understanding of what those limitations are. So our first Our Code activity mimicked this game, and not exactly the same, but we mimicked this game where you're moving around basically at a constant speed. And so you have this little circle, and initially you can only move it to the right by pressing the right arrow, but the student has to modify the code to get it to go in all the different directions. And so, for example, the left arrow, you have to put in Vx equals -10 to get it to go in the left direction. You have to put in, there's some code here to update the X direction. You have to update the Y direction as well. And so students can often kind of stumble through this just by themselves without even following the activities. They can get it. Younger students might just watch the videos and kind of put what's on that screen. That's fine too. So following that, we did an Asteroids game on our code. We did Lunar Lander, if you remember those games. We also were the first group to put a calculating the digits of pi activity on our code. And so it's the Monte Carlo method, as you can probably see. Obviously, we didn't invent the method, but we were the first folks to put a nice video up there. And then we made a Pong game, which talks about elastic collisions and how the kinetic energy is the same before and after. And there's also a game called Bonk.io that has a lot of fun, silly stuff of things bouncing around. This is my son and I were playing the game. And so you get to mimic that game as well. So this is just sort of part of the fun physics of video games activities that we have. Now in 2019, the activity that we made was inspired by this black hole image. Hopefully you remember that from the Event Horizon Telescope. And so we came up with a series of activities talking about escape velocity and sort of the dynamics around Newtonian black holes. And so that's up there on ourcode.com. We're quite proud of that as well. Now in the future, what you might see from us next year is, we don't have a video for this yet, but I constructed some activities based on the movie Hidden Figures. And so someone challenged me to do this. And so this is a simulation of an object in orbit that the orbit is decaying because of air drag, basically. And so the students will implement that air drag into the code. But then they'll also consider some equations, so you can model this with energy conservation. And ultimately the goal is sort of where is this going to land on the Earth, because that's exactly what happened in Hidden Figures, is that Katherine Johnson had to use her mathematics skills to double check the landing location of John Glenn's Mercury capsule. And the two agree rather well, and so that's exactly the same thing you do in this activity. You simulate it, but then you also use analytic expressions to try to come up with the same result. So that's one of the reasons why I really like this activity. I just built this in the last few weeks. We have many other activities that I don't have time to talk about here. Almost all of them have interactivity. Some of them are sort of press play and watch, which is fine. Many of them have some kind of validation for them. So I talked about how you can compare an analytic model to the Mercury project activity. We can do that same thing with many of these activities as well, which we think is a really important thing. We do not want the students to believe that complex simulations are right because they're complexity. We want them to double check it themselves. We have videos for almost all the activities on our YouTube channel. We're still working on catching up with that. One of the things I'm really proud of is that we recruit women and underrepresented groups from Ohio State University and also the University of Mount Union, where Rochelle Teeling-Smith teaches. We recruit them to appear in these videos so that students can see people who look like them, coding, having fun, and learning together. So that's something we're really proud of and we're going to continue doing. So you have the option of pointing your students to these videos to complete these activities, and in distance learning, sometimes that's the best thing to do, honestly. Or you can just sort of not tell them about the videos and just kind of hope that they kind of stumble through. So in any case, the link to our YouTube channel is here, and we hope that you find that to be useful. We put a lot of work into that. This is the learning management system that we have. We recently put this under a nonprofit, so it's no longer within Ohio State. It's part of a nonprofit that Rochelle and I started. And so we're just trying to cover costs with a nonprofit. So it's $20 per teacher per year to use this thing. The student use is completely free. You can enroll as many students as you want. And the idea here is that the students will complete the activities and submit the activities to you. And then you get a nice grid where you can look at the code submissions, run the code submissions, comment on the code submissions, and basically do the grading as fast as can be. I think you'll find that doing the grading without this is quite tedious. So we have over 500 students using it already, more each month. So send us an email here if you're curious about that. The last thing I want to talk about is something I was working on over the summer. And I was thinking about the different programs that analyze videos to see the dynamics of things. And I noticed that not all of them had object tracking. So these are the two main ones that I saw that use object tracking. But this one doesn't really work with Chromebooks. And this one only works on iPads and iPhones. So I wanted to come up with something that would work on a Chromebook. And so I started thinking about, well, what is an object tracker? And I think if you look at what tracker video and video physics are doing, there's some kind of sophisticated facial recognition that they do to say, all right, this is our object, even in front of a complex background. This is our object in frame to frame. And they do a very good job of that. But the thought occurred to me, it was like, well, what if it wasn't in front of a complex background? What if you just literally give your students a black poster board that costs $4, and then giving them a brightly colored ball, like a red or a green or a blue ball, moving in front of that poster board, and then just track only those pixels of a certain color. Could that work? And it turns out that it does. And so this is the program that I wrote that works great on Chromebooks. You can find a link to all that here. Jennifer Botten, who's a teacher in Cincinnati, helped record these. So this is a ball sort of rolling off of a countertop. And one of the nice parts of object tracking is that it allows you to have many object locations. If you're doing this by hand, advanced frame click, advanced frame click, you're only going to get maybe a dozen or two points before you start to get tired of that. So it's really nice for what we're doing, and the student kind of has to change this if statement to find whatever pixel colors that the object that you're tracking. In this case, it's a dark green ball. It's not actually a neon green ball here. This is just the tracking. But there's sort of a dark green ball that goes past, and so you can figure that to follow the colors. So this is my contact information. I hope you find this useful. I hope you have a great semester next semester. And by all means, please feel free to reach out if I can be of any help.